Hey Tech Team, I wanted to spend a few minutes talking about some live sound basics here at Momentum. We actually use the X32 system. It is made by Behringer. It's actually manufactured by Midas. Midas has one called the M32 that uses the same software. The X32 is just more affordable. Basic specs on the X32. We have 32 inputs, which means we can have 32 different signals coming in to the mixer. We have 16 outputs, which means we can send that output, whatever mix we have, out those outputs. We use outputs for our main speakers that are overhead. We use it for our sub speakers. We also use them to be able to send audio to the lobby and also to send mixes to their in-ears of the musicians. So the more outputs you have, the more options you have as far as how you can route information to different places. It's a completely digital board. It's got a built-in 8-bay effects processor, and each channel has a 4-channel EQ. If you look here in the top left, you've got this highlighted area. That is going to be where you can find your signal entering into the board. There's also phantom power there. So on an old analog board, every channel would have all the buttons, but because this is digital, you only need one set of knobs and buttons, and you can select which channel it's affecting. So that knob at the very left is your gain. It's like that first point where you're pulling signal from microphones or instruments. And then 48-volt phantom power is there. That is specific to particular mics. That's not a thing you're going to get into a lot. If you ever have something weird where it's plugged in, it's not working correctly, you can turn on phantom power. If it starts working, then you know that microphone required phantom power. After we get past those top two knobs, so the first knob on the left is your gain. The next knob is called a low cut filter, which basically will cut out the bassy part. You don't need a lot of sub bass or low bass in vocals, right? So you can add a low pass because that microphone will pick up all the frequencies it can hear. So if you've got a singer right in front of the drum cage or right in front of the bass cab, you can add that low pass filter to make sure it's not also picking that up and trying to recreate it. Once you pass through that, you see these got these next two knobs. That's a gate and dynamics. We don't use a lot of gates. Gates basically function like they're listening to the amount of sound coming through. When it hits a particular amount of sound, it actually opens up the channel so that the audio can flow to the actual main speakers or to the in-ears. So it's the equivalent of having a sound person just stand there and only turn the fader up when that needs to be up, but it can be very problematic, so we don't use it a lot. That knob on the right is dynamics. You can have a compressor or an exciter. We never have a reason to use an exciter or an expander, whatever you want to call it. A compressor basically takes the short or the little volume of a particular sound wave and the big volume of a particular sound wave, and it squishes them together so that it sounds more even. So this is a really great way to get rid of some of the shakiness in a vocal or to make sure someone doesn't overload the system. The next thing that we get into here is that really is your EQ bay. There's an EQ bay there. You've got four. You basically got low, mid, and high. You can roll them anywhere in the frequency range. You've also got a couple different options for the style. Low cut, low shelf, high cut, high shelf on the top and the bottom, which those are only affecting the low and the high. And then the two in the middle can do all four, which you've got a vintage EQ and a parametric EQ. I prefer the vintage EQ because it's got a softer slope. That's basically determining what kind of curve is going to exist inside of your EQ, which you can actually see on screen, and then you can determine how wide that curve will be using the Q, and then you can roll those across all frequencies to either accentuate or remove a problem. Then you get to the main fader strip, right? It comes out of there, it comes into the fader strip. That first button that you see there, that green button, is the select button. When you press that button, it makes everything above that part of that channel. So right now in this picture, channel 1 is selected, which means all of the stuff, the gain and everything, is affecting channel 1. If you were to click the select button on channel 16, then all of those things would affect 16. You've got a level meter there, which is basically like a visual version of your signal level. If you've got clipping, then your gain structure is too high. We talked a lot about gain structure. We've got to make sure our gain structure is proper before we get into anything else. The solo button below that basically allows the sound person to only hear certain things in their headphones from the board. So like, let's say you want to hear only the guitars. You can solo those 3 guitars, and that'll be the only thing that goes into your headphones. Then you got a scribble strip, which is that little LED screen that'll tell you what it is. Is it a singer? Is it a guitar player? What is it? And then you've got a mute button, and then you've got the actual fader. Right next to the screen up on the top there, you've got a little section there where you can assign channel signal to the mains or the mono bus, right? At Westridge, we use both. The mains basically go to the top speakers that are reproducing sound in the auditorium, and then the mono buses are subs. We split those out so that if we ever need to add more or less bass, we can do that, which is really effective because we use way more bass on a Wednesday than we would on a Sunday because it's 2 different people groups. Then you've got 4 buttons to the left of channel 1, fader 1. Those 4 buttons allow you to change channels, right? So button 1 would be channel 1 through 16. Button 2 is channel 17 through 32. Then button 3 does your aux ins and your FX returns, and then button 4 is your output buses. Why is this here? Because this board does 32 channels. If you were to build this board so that every channel was represented, it would be enormous. But because it's digital, you can actually use the same hardware to accomplish different things. So right now, 1 through 16 is selected. If you press that next button, it's going to turn green. And channel 1 is then going to turn into channel 17, and you can affect the other 32 channels. It keeps the board smaller and lighter. The 5 buttons in between the input and the output section are very important. You've got a button at the very top called Sends on Fader. This is how we can set the level of output per channel to a particular output. Where we see this the most is in our in-ear monitoring. So you can go to the in-ear monitors 1 through 8 of the mix buses. You can hit Sends on Fader, and then you can essentially just set the volume of the single channel selected to the musician's ears. You've got 4 buttons below that. First one is a DCA group, which is basically a way to join channels together so that you can make quick movements across their volume. So we might have a channel that says strings, which is every stringed instrument. Let's say you just want all of the strings to come down a little bit and not a particular guitar. You can actually bump that down just a little in the DCA group, and it will do that. And then you've got, right below DCA, you've got mix buses 1 through 8. Next button is mix buses 9 through 16. And then that last one is matrices and the mono signal. So if you need to change the subs, you go to that last button, and it'll be the very last fader right next to the main fader. You'll also see there are fills there. You don't ever touch those because they adjust according to the left and right signal, so you don't ever have to touch them. As I said, that very last fader is your main fader. This is how much volume or how much signal you're sending to the speakers to recreate the sound in the room. At the top, you've got a main display area. This is going to show you like a ton of pertinent information. It allows you to configure the board as well. The things that you're going to use this the most for are adjusting compression or adjusting the EQ. Every single section that we have looked at has a tiny little button that says View. If you press that View button, it will bring that particular page to this screen so that you can see what's going on. So if you press channel 1 and then you hit the View button on the EQ section, it will bring up the visual EQ that you can see. If you wanted to see the compressor, you hit the little View button next to Dynamics. It will bring up the options that you have there. Next to that, you've got buttons to the right. Home brings up the current channel's home screen. Meters button will show you numerous meter readings, so you can see all of the signals for the whole board in the meters. The routing button allows you to change the routing of the inputs and the outputs. You should never need to be in routing unless there's a serious problem or a serious change. And it is not for the faint of heart, because you can definitely create problems. You can't break anything, but you can create real problems. Setup contains the initial settings for the board as well as some network information. Library will contain all of the saves, so like every singer, every musician, their saves will be in there. There's also scenes in there. Your effects button gives you access to the 8-bay digital effects processor. The last effects processor in channel 8 is our room EQ, so you never need to mess with that. And then effects 1 through 4 are the effects we apply to vocals and instruments. You don't really ever need to set the parameters in there because they're set pretty well for the room. Then you've got the mute group button, which is used to set up mute groups. The buttons at the Westridge board, full disclosure, for the mute groups are a little sticky. So I tend to use DCA groups or just mute individually. But if you wanted to set up mute groups, that's where you would do this at. And then the utility button is used to load and save presets as well as modify the scribble strip for each channel. So like to set the name and the color of the little screen, that's where you would do that. As it said here, the 2 lighter options in setup and routing, you don't really ever need to be there. Sound techs. Here's what you need to know. You are in a position of knowledge. You know a bunch of things that other people don't know about what's going on in the room. You're thinking about sound pressure levels. You're thinking about how many people in the room. You're thinking about how these different things work together. So you're going to hear a lot of opinions. And what you need to know is that knowledge really is just for us to do our best to help everyone in the room. We don't ever want to be in a position where we feel like our knowledge has made us superior to anyone. Knowledge really should be a tool for what's going on. You need to have some knowledge of music. You don't have to keep perfect time, although it is helpful. It would be really hard to do sound if you were totally tone deaf, but it's literally not impossible. But you want some basic knowledge of music. You most definitely want knowledge of the music that you're actually mixing that day. So you want to listen to stuff before it happens. You also want to be a critical thinker because there's going to be things that happen and people are going to look to you to fix those sound problems. If there's something going on with a mic or there's something going on with a musician, you got to keep your head cool and you got to stay in a critical thinking mode. Like, okay, what is the most logical place where this particular signal is breaking down? Where this plays out also is that you're not only solving problems, but you're also setting the tone for the band. So if you freak out, the band is going to freak out. So no matter what, you need to stay calm and cool and collective and approach everything from a critical thinking standpoint as opposed to there's a fire standpoint, because that energy can really change the way a morning or a Moxie is going. You need to have you need to be able to communicate well with the musicians. So like you've got to do a really good job of being able to communicate with the musicians, make sure you're watching and listening to what they need, but then also you're communicating with them like, hey, I really need you to play harder here so that we can set your volume level correctly. And how that translates the best is the better you communicate, the better their in-ear mix will be. And the better their in-ear mix will be, the more comfortable they will be and the better they will do on stage, which lowers distraction and makes it much better for the people who are sitting in the main space. You want to be friendly, you want to be lighthearted, but there is a time and a place to speak firmly. Like there's just a point where you have to be like, hey, I have to do this before we do this. Or, hey, I hear what you're saying, but I can't do that until we get to here. You need to have some understanding of basic sound theory. We covered some of that, and we'll cover a little bit more. And then you need to know that you're serving the band and you're serving the house. We serve everyone. Here's a quick cheat sheet on tonal spectrum and overlap. Okay, so on the left side of the screen is the lowest frequencies, which would be like 20 hertz. On the right side of the screen is 20,000 hertz. If you look here, and you can look in your download, or you can look in the folder in the booth, you can actually see the different places of main. The solid part is the bass frequency, and then the lighter is the harmonics. So if you look, actually, the vast majority of the stuff that we listen to covers a lot of the same frequencies. Nothing covers quite as many as a piano. It is just a full-on deluge of sound. So as sound people, we need to keep that in mind because it can eat everything up. But you've got all of these different things competing for relatively the same section of frequencies. On top of that, you've only got so many speakers that have to recreate that frequency. So if you haven't mixed it well, or your EQ is off, and let's say you're just overloading somewhere around 1500 hertz, right? 1500 is your frequency. All of the, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All of the 10 speakers in here are going to try to recreate that frequency based on every single signal, which is why sometimes it can feel muddy. So we have to be really intentional with our dynamic mixing during the service, and we have to be really intentional with making sure our EQs are helping and not hurting. Here is basic sound flow. It's a little bit like water. You start at an input, which in regular home terms would be the water authority or the water plant. Here it would be like a mic or a guitar or keys or whatever. It's going to come into the mixer, and it's going to go through the gain knob, which is like the first faucet. It's going to come out of that, and it's going to fork out to the monitors, which would be our in-ear monitors, or maybe even to the lobby, and then it's going to come out of that after it has processed inside of our board to the main speakers, to the amplifiers and the speakers. We actually, at the Westridge campus, we run a mixed environment. Two of our mains use external amps like this picture shows, and then the other three actually have built-in amps. At our Forsyth campus, they're all built-in amps. They're called active speakers as opposed to passive speakers. And as we refresh campuses or make changes, we will move to a completely active system. But hey, these two passive EVs that have been at Westridge have been here for like 12 or 13 years, and they're freaking kicking it. So, you know, if it ain't broke, don't fix it. Mixer basics, you've got coming through your trimming game, your phantom power, your low and high cut pass, we covered that, your dynamics, your EQ, your aux sends, which is actually how we send to our matrices. Panning left and right is relatively simple. How to mute, we did. Solos and the volume faders. Okay. Sound mixing in a live environment is fluid and a changing process. You should be checking the room by walking the floor to see how sound is reflecting and to have a better understanding of the current mix. So specifically at our McDonough campus, the room is maybe 55 feet deep. The low E on a bass guitar, that wave is 30 to 36 feet long. 32 feet long. I've been updated that it's exactly 32 feet long. So that wave is coming out of those speakers at 32 feet, and it's going to hit that back wall, and it's going to bounce back. Why does this matter? Because where we're at in the sound booth is going to sound one way, but because of the way our room is laid out, it's not in a cathedral style. It's in a wider, more inviting style. The stage is lower. All of these things come into play when it comes to actually mixing. So as the band is practicing, you want to get your mix where you feel like it sounds good, and then you want to walk left or right at different depths of the room to figure out if your mix is translating across those different spaces. You want to utilize the soundboard to keep the sound dynamic, which basically means like there is no set it and forget it in a Momentum or a Moxie service. You have to dynamically be mixing inside of the songs and in between the songs. You can't just say, this sounds good, and then sit down and get on your phone. You have to literally listen to the whole song the whole time, make micro adjustments, or sometimes even large adjustments. This one is super important. All criticism from other people is beneficial. All criticism from other people is beneficial. Now, maybe it's not life-giving. Maybe they're a Karen. Maybe they've decided they know more than you. All of those things are true things that can happen. And maybe you're dealing with a jerk or somebody that's overbearing. I get it. But deep down in whatever they're talking about, there is something beneficial for you to learn as a sound man. Anyone telling you anything that can help you, that can help you improve your sound mix. It doesn't mean necessarily that you need to change anything, but you do need to learn to take what people are telling you and go, okay, what can I learn from this for the next time? Fixing issues. Here are your basic problems in live sound. You got no signal, you got feedback, you got distortion, you got noise, or you got hum. If you got no signal, then you got nothing coming into the mic. Is the mic damaged, right? Does it need phantom power? These are the first things that you want to look at. If you can see that the mic is not phantom power and that it is getting signal, the mic is fine. If you can't, switch the mic out, and if the problem goes away, then you know it was the mic. If that's not it, if there's nothing coming through the cabling to the board, you basically have to figure out, is there a bad port on the stage where the mic plugs into? At the stage box, is there a bad line in our snake or a bad port on the board? So if you've got a wired mic, it's got a wire running from the mic to the floor. That floor wire runs back to the sound booth, and it plugs into the back of the soundboard. Somewhere between the microphone and the soundboard, there's a problem. These are all of your points of failure. Now, let's say you've got signal coming into the board. Boom, you can see it on your little meter reader on the channel. but you're not getting anything from the fader. Uh, then you've got something plugged into an insert, which we don't really deal with here because it's a digital board, or you've got a broken channel gain. Let's say your gain knob is not turning, or you have a routing configuration. These are problems you might need some help with. You definitely don't want to be digging around in anything that you're not sure about, so you can get with Matt or me or Zach or whoever is available to figure out what's going on there. Now, let's say you've got it all the way through the board, but for whatever reason, it's not coming through the mains. Like you can see that the channel is working properly and the fader is working properly, but it's not coming through the mains. Is the channel muted? This happens. Is it not assigned to the mains or a sub output, right? So one of the ways this can play out on an X32 is like, let's say you just literally don't have it assigned to the mains. For instance, our MD microphones are never assigned to the mains so that you can't accidentally put the person on stage talking to the band into the main speakers. If you accidentally push the button that assigns a channel to the mains, even though you're sending full signal, it will not go to the speakers because the board thinks you don't want it there. In the same way, if you've got it assigned to a DCA group and the DCA group is turned down, it's not going to come through the house. Now, let's say you've got signal to the house and everything, but you don't have it to their in-ear monitors, right? You want to make sure that it's not turned down in their mix. You can individually mute channels into a mix group. So you want to make sure you hit the Send Zone Fader button and make sure it's not muted. And then you want to make sure there's not a routing configuration problem. If there's a routing configuration problem, they're probably having trouble with their whole mix, which is going to need a little bit more help anyway. Feedback. All right, so feedback is that thing that you hear where like the speakers squeal or they hum really loud. If the channel signal gain is loud enough to pick up signal from the main or the sub. So let's say you've got a singer and you've got the gain on that microphone turned up so loud that when the singer sings into it, it comes through our system and it comes out the main speakers. But when it comes out of the main speakers, the mic is so sensitive that it picks up what's in the main speakers and it reprocesses it over and over. It's going to do it so quickly that basically it's going to increase the amplitude, the volume to the point where it turns into feedback. That can happen with your mains or your monitors if you're using wedge monitors that are open air. All of our monitors are in-ear, so the only time it's going to happen is if it's picking it up on a sub or a main. This can also happen if your microphone pickup pattern is too wide, which basically only happens if you're using the wrong kind of mic for the wrong kind of application. You don't want to hand a singer an omnidirectional mic because it will pick up all of the room noise as opposed to just their voice. And then the other thing that can do it is if your microphone is damaged. Distortion, right? This happens if your input gain signal is too high. What happens is basically if you turn up your input gain too high, whatever signal you're bringing in is literally coming in. It would be the equivalent of if the water valve at your house, if you could open it up to like 200 psi, right? Like it's going to burst the pipes in your home because they're not designed for that much pressure. In the same way, if you turn your gain structure up too high, the digital circuits, even on a board that's not digital, the analog circuits, it's too much signal coming through. This can happen a lot with musicians or with vocalists, sometimes with musicians. It can be created by fluctuations in the vocalist's voice. They come in, you set the gain structure, they're being very timid. 2 songs in, they start belting at the top of their lungs, and now you've found that your gain structure is too high, which is why it's important to make sure that we're always asking them to push as hard as they're going to push in a service. They're not going to be able to, but you can at least get closer. You can also have an issue where a musician has adjusted the volume after the channel gain has been set. Some guitar player has set everything up. We've got our gain structure set, and then right before service, he decides he wants to push it to 11, and now you're overloading. Especially on an acoustic or something like that. It's a little harder on a closed loop with an electric where there's not an open mic. But some acoustics have literal open mics, and they will for sure distort. Sometimes people accidentally put an expander or an exciter, which is basically like they were in the compression settings and they accidentally switched it from a compressor to an exciter. Sometimes it can be that your EQ is so overboosted that you're overloading the signal. You should not really have huge mountains. You should have little peaks and deep valleys for your EQ. You shouldn't be way over 0. Sometimes your main signal can be too high. Sometimes your amplifiers to your speakers can be set too high. Like maybe everything on our side of the board is good, but the amps in the back have been turned up too high. We actually had this at Westridge a couple months ago. People started complaining that there was something wrong with the right side of the room. So I came in and did a bunch of investigation and found that the amps that control the main on the right, some little fingers got back behind stage and turned them all the way up, which is, I'm going to say, literally 100% louder than they need to be, which made it way too bright and loud on one side of the room. So you got to watch those issues. Noise. You can get noise if your channel gain is set too low, or if your pickup pattern is too wide. Maybe your vocalist is too far away from the mic, or maybe your cable is unbalanced, or there's a break in the shielding. All of those cable issues can exist from the source all the way to the board. So it could be the wire that the mic is plugged into, it could be the snake, it could be the board. Basically noises that most times people will associate it with, like the low end sound that you can hear when something is turned up too loud, or maybe there is a little bit of interference. And then hum. Hum comes from an unbalanced signal. A balanced line basically takes whatever's coming through the line and then inverts the signal 180 degrees. Then at the board, the mixing console will literally look at those two, and it will apply an equation to the two, and anywhere the two don't match, it cancels out that signal. That way, if you've got interference coming down, it will adjust those two frequencies out of phase from 180 degrees. And then the board can go, oh, whatever that is isn't from the original source, so I'm going to cancel it out. So if you have an unbalanced signal where it's not sending both channels, you can get that. You can also get it from a ground loop or power interference. Hum a lot of time will be connected to lights, and that is the vast majority. There is one other thing that I think we could do that would be kind of fun. We'll see if I can pull it off. Give me a second here. Let me see if I've got the keynote on here. EQing can take a long time to get used to. And one of the things that you have to do first is you have to learn, like you have to train your ears on frequency, right? I'm going to give you some different terms that are pretty normal in the sound world. They shift a little bit, but once you've done it for a little while, you kind of know what people are talking about depending on what they're saying. I'm going to play a particular audio clip, and then I'm going to isolate those different frequency ranges on that same audio clip so you can actually hear what is happening when we listen to those. So let's listen to it first. I dare you to move. This is at between 120 and 150 hertz. I dare you to lift yourself up. I dare you. A little bit higher. I dare not too much. I dare you to lift yourself. Then we're going to move into the section where I feel like people have some of the largest problem, which is boxiness. I dare you to move. I dare you to move. I dare you to lift yourself up off the floor. Then we're going to move up into the section where you're usually, if people are complaining that it's hurting their ears, there's probably an issue in the next two phases. So the first one is bite. I dare you to move. I dare you to move. I dare you to lift yourself up off the floor. Presence. I dare you to move. I dare you to move. I dare you to lift yourself up. The next one is sibilance, which is where all of the sounds exist. I dare you to move. I dare you to move. I dare you to lift yourself up off the floor. That's basically it for live sound. There's a bunch of stuff you can learn. There are unending resources. If this is something you're interested in and you'd really like to dive in, you can reach out to me or Zach or Noah or Matt, and we can get you some resources where you can really excel in this. You can learn a lot of things. And I can tell you for sure, this is also a skill that you can take into the world outside of church. There have been plenty of times where I have got to do some pretty fun things because I knew how to run live sound. On top of that, it's just a really wonderful skill set to have. So hopefully this has been helpful for you. If you have any questions or anything, just hit me up. I'd love to talk to you about it. Thanks, you guys.